Wow, this is nice. I feel a little bit like the lion in The Wizard of Oz when the wizard put the medal on him and gave him courage. It's nice to be here. I am flattered and delighted to be given this honor. I didn't prepare a lot of slides, so I'm going to pantomime some of my things here for you. My interest in dexterity and robotics goes way back. Sometimes when I go through my mom's house, I find little fingers and things that I was making when I was a very young kid. And I've always been interested in physical things, whether it be one Christmas, all I wanted was a piece of rope that I could splice, because that's what I wanted to do. When I went to MIT, I got into lock picking, and it's a tradition, okay? And actually, I got into that before. I'm sorry. Oh, yeah. Yep. And sleight of hand magic, things with hands. I noticed that I don't do dynamic tasks. I've never been good at juggling. I can't do skateboarding or any of that. But I'm very interested in touch communication. So instead of changing the informational state of things, I'm interested in changing the physical state and not just perceiving the patterns in information, but changing the physical state and perceiving the physical state as you're doing this. So this has led me through a very interesting path of devices. The Stanford JPL hand, which eventually was called the Salisbury hand by other folks, was something that Bernie Roth, who was my thesis advisor, he was here, he'll be back, tolerated and encouraged. And I thought it was just going to be a little gadget that would grasp things and let us study grasping and manipulation. And then one day the General Motors folks, the head of the GM research, came to us and said, "We want one of those hands." And I thought, "What are you going to do with it?" And they said, "Well, we're going to put transmissions together with it." And I said, "That's going to take a long time." They said, No, we're GM, we can do it. Well, about 5 years later, they weren't putting transmissions together, and I convinced them to give the hand to another research group. And so that little hand became the foundation of Salisbury Robotics, which was me and a file cabinet and a bunch of machine shops that built my hands. We probably made about 20 of them. And they became platforms for people to study machine dexterity and perception. But something I got out of that was, hey, it's really fun to make a platform that, maybe my intuition led me to design something that was good, but I didn't know how to code up, actual perception or actual manipulation beyond a certain level. So this thing took on a life of its own, and other people did things with it that I never could have imagined. We put sensors on it, but I still didn't really know what to do with it. But other people managed to screw things together and perceive what's going on and begin to do these things that I was doing at home when I was picking locks or tying knots. So I sort of realized that making platforms was one of the places I wanted to go. I had certain insights about how things should be built so they're controllable and interesting, but I wanted to give them to other people. And so we've spawned quite a few things over the years. One of them was the WAM arm. It was an arm that we thought about, instead of being a positioning device, robots that descended from the machine tool industry, I was exposed to some of the pioneers in teleoperation, Jean Vertu from France, Tony Batesy from Transylvania, from NASA. Okay, I have to tell the Tony Batesy joke. He called me one time. Tony was a wonderful man who worked for NASA, developed force sensing controls, some of the early dynamic control of robots. And he called me one time and he said, "Hello, may I speak to Ken Salisbury?" And I said, "Oh, hey, Tony, how are you?" And he said, "Oh, you recognize my voice." No, he was a good man and had a lot of influence on me. Also, John Hill, who was one of the people at SRI, where I worked for a while. John was one of the co-inventors of a lot of the technology that ended up at Intuitive Surgical. It was a sort of a strange coming back together. At MIT, we developed some telesurgical systems. And eventually that became part of the Intuitive Surgical portfolio of patents. And I spent some years as science advisor with Intuitive Surgical. And that, for me, was another interesting experience in that I'd mostly been working on sort of theoretical applications of robots for NASA applications that never flew and for undersea tasks, some of which did get performed. But when I got exposed to the medical industry, I began to realize that this stuff I was learning to do, had been learning to do over the years, in dexterity and human in the loop, had real clinical value, and that I could learn from the doctors. A lot of the surgeons think physically as I do, but they use a different vocabulary. And so my job became sort of translating what the doctors wanted in their vocabulary into a vocabulary that the engineers could understand and help them implement a system that could do surgery well beyond the limits of the human hand, as they say. And in fact, some of my friends out here in the audience have had surgery done with this robot, and it's sort of gratifying to see things that I was there when it was a fledgling device turn into very practical and meaningful devices. What else have we done? Oh yeah, then there's haptics. The word haptics used to mean the study of human perception. How well can I tell the difference between a hot and a cold thing, or a sharp thing, or 2 points touching me? But somewhere around the mid-90s, we began thinking, how do we physically interface to virtual physical things? How can we touch an imaginary ball or an imaginary tumor if we're trying to train somebody to palpate and know the difference between a cyst and a cancerous tumor? And in fact, I gave one of my students, somebody who was a very capable designer and machinist, this is Thomas Massey. I said, well, I want to be able to feel things on the screen. I want to be able to feel like I'm squishing a bug or moving through molasses. And this kid, came back a week later with a 1 degree of freedom haptic device that simulated a wall. And 2 weeks later, he came back with a wooden model. And within 6 weeks, we had a virtual environment that we could touch and feel virtual things. And that has grown into a company of its own and gone on from there. So there are lots of thanks in order here. I've said some of them. Sebastian, John McCarthy. I don't know if John's with us here today, but I definitely appreciate that. I had the privilege of getting to know both John and Marvin Minsky, the two of the main pioneers in the beginning of AI, and they've sort of given me encouragement along the way. Also, thanks to the admissions departments. Now that I'm on the faculty, the admissions departments are the fuel for our engines. They're the people that let in the good students that help us implement our dreams. So that's it. Thank you.